Hello students, I am here with another video from the chapter of class 10th NCERT book, that is Periodic Classification of Elements. So before starting today's video, I would like to tell you all that till now what all things we have discussed in this chapter. So we started with this chapter with the word of classification, which means that we are going to arrange the different elements on the basis of their different similarities as well as the differences. Okay, so we need to, why there is a need of classification? So there is a need of classification because the classification is required because there are so many elements to be which are present now, and at the earlier times also it was present. So there was a need to study each and every element in a very in a best possible way. So it was only possible for the scientists to understand the various concept of each and every element when it is to be classified, or when it is being classified and it is kept under a group, or it is kept under a classification part. Fine. So we need to classify the things to avoid confusion, to avoid chaos for studying of these different types of elements. Okay. So why it is known as to be the periodic classification, children? So this periodic classification is required because this classification was done on at different times, okay, at different time intervals. So the very beginning, the very basic concept of this classification was given by the first scientist, whose name was Bhanupriya. So he gave this classification on the basis of the arrangement, which was based upon the increasing order of the atomic masses. Now, when the arrangement was done on the basis of the atomic masses, then he found that a group of 3 elements are there. Means he has arranged, because very small number of elements were discovered during that time, and then he found that there is some connection between these elements. So what connection it was having? The connection which it was having was that when he arranged the elements of 3 in number, then the first and the third elements atomic mass average was approximately equivalent to the atomic mass of the middle element. Okay, so this was the first classification, and in the very beginning it was this concept, this was a bit successful. But after that, what has happened, when more and more elements were discovered, then this tried experiment was not successful at that time. Fine. Next classification was given by the next scientist, whose name was Newland. And he gave the law of octaves. Now, what is this octaves? Octaves means 8 in number. So whenever the arrangement was done from 1 to 8. Many elements were there, and at that time, the elements were there, and these elements were again arranged in the form of ascending order of their atomic mass. Why? Because these scientists also have got an idea that there is one connection between the atomic masses. So they all started working over the same concept, and they started increasing the concept. So when they were increasing the concept, they found that if we are arranging these elements according to the ascending order of their atomic masses, so we could see that every 8th element is going to repeat its property. Okay, every 8th element was very similar to the first element, and this was being connected with the notes of music. Okay, so this was again a story. Then again, what has happened? The third classification came because the second classification was also stopped because of it was not being able to apply after calcium. Since the discovery was going on at a very rapid rate, and once the discovering of the elements were happening, so we cannot put these elements anywhere in the periodic table. So there was no fixed position in the periodic table where we could include these newly discovered elements. Once these elements were means they were put inside that, they were adjusted inside that particular periodic table, then what has happened? So this was continuing. The concept of the octaves were continuing till the calcium. But after that, what has happened, it was not being able to classify the further elements. Why? Because there was again a very much difference in the atomic masses. Now next, the third classification which came was this Mendes classification. Okay, so we studied about this Mendes classification also, where he has taken not only the atomic masses, whereas the chemical and the physical properties were also taken in consideration. Okay, and then after that, what has happened is that the merits were also present. So what were the merits? Merit was that he has left some space in his periodic table so that the newly discovered elements would have been placed over there. Okay, and after that, what has happened, there were certain limitations also which we discussed it yesterday. So these limitations were, the first, the placement of hydrogen was not proper, because the properties of hydrogen as well as the compounds which was made from the sodium was having the same property. Okay, so as it was having the same property, it was not having the particular place in the periodic table, children. Okay, next limitation was this isotopes were also discovered, but that disturbed the complete periodic table. Fine. So when the complete periodic table was disturbed, then it was not being able to follow the rules, and it could not be adjusted, the elements could not be adjusted because of the presence of these isotopes. As the definition of isotope says that it has the same properties, whereas it has a different atomic masses. If it has different atomic masses, it could not be added in a particular part. I mean, hydrogen, if it is having one atomic mass, then the atomic mass of the deuterium is 2. We cannot add that 2 means the isotope of hydrogen in the particular hydrogen part where it was kept. Okay. So this was made very difficult for the scientists because the isotopes were disturbing the periodic table. Fine. After that, there is an increase in the atomic mass, was not in a regular manner. So again, why it was not in a regular manner? Because the discovery was not being done in a proper way, at a proper pace, but it was taking any time. I mean, the elements which were discovered, they were not having a particular they were not having a particular regular fashion. I mean, they were discovered randomly, and when they were discovered randomly, they would have been placed at a particular position, and they would have been placed at a particular level and a particular place where the place was left empty. It was, if the atomic mass has matched, then they would have been adjusted over there. That place, that missing place was present. And when the elements, if it was discovered and has to be kept in between, that disturbed the complete periodic table. So these were the limitations of the Mendel's periodic table. Now, with this limitation, the other scientists also got some concept of classifying the things in a better way. So the concept of next periodic table has come. So what was the next periodic table? The next periodic table was the modern periodic table. What was the next concept? It was the modern periodic table. Okay, so this was the next concept of modern periodic table, children. Okay, so when modern periodic table has came in the concept, then what were the different, I mean, there were different features of this modern periodic table. So what were the features of this this modern periodic table? This was in 1913, yes, in 1913, Henry Moseley showed that atomic number of the element is a more fundamental property. So till now we were all discussing only about the atomic masses. The first thing he has taken was the atomic number. He has taken atomic number into consideration. Not only atomic mass, atomic number was also taken. Why? Atomic number was taken because this atomic number was the more relevant, or it was more reliable concept rather than to take the atomic mass. Okay, so the Henry Moseley has taken the atomic number of the element as a more fundamental property than atomic masses. Okay, so now why, as I have told that this was having a more fundamental property, because this was just the concept that if we take the atomic masses also, then what will happen, it is going to give you some information which would have been different if we took this or if we have taken this atomic number into consideration. Okay, this was very much different. So here what has happened, that this modern periodic table was based upon the atomic number, not only the atomic masses. So this was more reliable concept for adding the different properties of different materials or these elements, because it was based upon the atomic number. Okay. Now next thing, which was being placed. So here, according to Mendes periodic law, the modification of atomic number was adopted on the basis of modern periodic table. So please remember, this concept of atomic number was the first feature of this modern days periodic table. Okay, because here the atomic mass was not taken. Instead, they took atomic number for studying the properties of different elements. Okay, now properties of elements are a periodic function of atomic number. Why this atomic number was taken? Because this periodic function was due to the change in atomic number. Okay, so this was because of the change in the atomic number. So please remember that whatever variations were coming in this periodic table was due to the presence of this the difference in the atomic number. Okay, so this was a very particular concept regarding this modern periodic table, that the periodic functions of the elements were based upon this change in the atomic number. Okay, now what are these functions? That this could be the difference in the properties. What do you mean by this word here? Periodic functions means the difference in the chemical properties, physical properties. Okay, so many chemical and physical properties we are going to study in the trends of modern periodic table. Okay, now next thing, let us recall the atomic number of the given that gives the number of protons in the nucleus of an atom, and this number increases by 1 when we move from one element to the next one. So why there is a change in the atomic number? Because the number of protons are increasing, the number of protons are changing in the nucleus. Okay, so whenever the number of protons are changing, it is going to change the atomic number, because atomic number is equivalent to the number of protons, which is equal to number of electrons, which is equal to the atomic number. Okay, so this atomic number is equivalent to the number of protons present in the atom. Fine. So this was because there was one increase. There is increase in number 1. It is going to increase by number 1 when we move from one element to the next element. Okay. So this was the basic concept of this modern periodic table. Fine. Next is that, see, this could be the next feature. So this atomic number increased by 1. So what could be the next feature? The next feature could be this atomic number is going to increase by, when we have arranged the elements, so it would have increased by the atomic number would increase by 1 when we move from one element to other. Okay, so when we are moving from one element to other element, it is going to increase by 1. Okay, children, so this was about the two features of this modern periodic table. Okay, there were more features of this modern periodic table. We'll discuss it one by one. Now next thing is that the elements, when arranged in the order of increasing order of their atomic number, Okay, atomic number, if you remember the to write the, this was ZXA. So what is this? Z means this was atomic number. X means this was the element, name of the element. And this was atomic mass. This was atomic mass. Okay, children? So this is about the depiction. This is how you are going to denote any element with its atomic number and atomic mass. Okay. So when we are denoting this ZXA, it means that atomic number is always denoted with the Z alphabet. Fine. Now, when the elements are arranged in the increasing order of their atomic mass, atomic number, that is Z, leads to the classification which is known as modern periodic table. So what is this modern periodic table? This modern periodic table means, it means that whenever the classification is being done on the basis of what? On the basis of only the atomic mass, atomic number, not on the atomic mass. Please remember that this classification, this whole classification of modern periodic table was based only on the basis of the atomic number, not on the atomic mass. So this was the main basic difference between the atomic number and the classification, the previous classifications and this modern classification. Okay. Now, why there was less mistake in this modern classification? This is the most acceptable. Please remember, this is the most acceptable classification of the modern periodic. Which is known as the modern periodic table. Why? Because it has changed its basic idea. The basic idea was upon this atomic number, not on atomic mass. Okay, so the elements were arranged on the basis of the increasing atomic number, not on atomic mass. Please remember this. Okay, so this is the basic concept. And how would you define this modern periodic table? The modern periodic table would be defined as it is the classification of the elements on the basis of their increasing atomic number, not on their atomic mass. So if any classification is being done on the basis of the increased atomic number, not on atomic mass, is said to be as the modern periodic table. Okay, so this has more element as compared to the Mendel's, as compared to the Dauvergne, as compared to the Newland's periodic classification. Okay, so it has more element included in it. Okay, now the predictions of the properties of the elements could be made with more precision when elements were arranged on the basis of increasing atomic number. So what was the advantage, or what was the next feature? The next feature of this table was that whenever atomic number was taken into consideration, so this was increasing in a regular manner. First of all, this atomic number. Second means this atomic number was increasing in or by 1, okay, by 1 in number. Similarly, the next thing was that the properties of elements were studied or were explained more with the more precision. Okay, this was being studied under more precision. Precise means this could be more apt, or this could be more explained in a well-mannered way, or this was most appropriate one. Okay, so the concept regarding this atomic number was the basic idea of the classification of this table, because of which it got success also. Okay, so the success was based only on this atomic number, because the number increased by 1 only. There was very less difference from if we are jumping from one element to the another element. Okay, fine. So because the properties of the elements were studied more precisely, therefore the concept was being, the elements were arranged on the basis of the increased atomic number. Okay, children, so what was the position of different elements? Now let us see what is the way by which this modern periodic table is being drawn. As you could see the diagram which is given here in our NCERT book, as on page number 86 of your book, you can see, look into the diagram of this periodic table. Okay, So next, as we can see, the modern periodic table takes care of three limitations of Mendel's periodic table. The anomalous position of the hydrogen can be discussed after we see that the bases which were having the position of the elements in the periodic table, which depends. Now we will first discuss the positions of the elements in the modern periodic table. So this has also taken care of. So what was the fourth point? This modern periodic table has taken care of limitations of Mendel's periodic table or classification. Okay, so what was the main concept? This has taken care of the limitation of those three limitations of Mendel's periodic table. Okay, so this, please keep in mind that this modern periodic table was the most acceptable one, and this was done because of the presence of the different elements, and at that time many elements were discovered, almost all the elements were discovered, and this was based upon the atomic number, not on atomic mass. Okay, so now we'll study about the position of the elements, position of the elements in modern periodic table. Okay, so what was the main concept, or what was the main criteria of the modern periodic table? So what was the main classification of the position of the elements in this modern periodic table? So what kind of position every element was occupying? Let us discuss that. So the position of elements, as this was a very long table, and the modern periodic table has 18 vertical columns. So how would you classify? How would you write down the, so it has 18 vertical columns. Okay, so this was the first feature. Then second was, it was also having columns were known as 18 vertical columns were known as the groups. Okay. Then the second point was that there were 7 horizontal rows, 7 horizontal rows known as, this was known as the periods. Okay, so this was known as the groups. The 18 vertical columns are known as, this is known as the groups, and 7 horizontal rows were there. This was known as the periods. Okay. Next thing what we will discuss is that when we have to see the placing of each and every element of a certain group or a period. Okay. Now we'll find that all the 3 elements containing the same number and the valence electrons, they were placed in the first group. Okay, so number group was being made if we see the first group. Okay, so these were the 2 main characteristics, that whatever vertical columns are there, so 18 vertical columns were there. So how would you write? Like 1 2 3 4 5 till 18 you are going to write. Okay, then this was known as the groups, this was known as the group. Okay, and there were 7 periods, 1 2 3 till 7. Okay, so this is known as the 7th seventh group and the period. Okay, now what else, how we are going to see? This is known as the group number, and this is also known as the period. So this was known as the group number, and this was known as the periods. Okay, so this was 7 in number, this was 18 in number. So this was about the modern periodic table, and you could see the complete diagram of the modern periodic table in your NCERT book. Okay, children. So children, this I have drawn a simple diagram of this modern periodic table as see, it is difficult for me to draw such a long diagram here on the board, but still I have tried to draw, but I'll just explain you the concept. You can keep your book in front so that it becomes much more clear about the concept of this modern periodic table. Just I wanted to tell you that there are different arrangements of the groups, different arrangement of the period in the horizontal as well as the vertical column. So these vertical columns are known as, these are the vertical columns and they are known as the groups. And how many groups are there? 1, 2, 3, 4 till 18 groups are there. And how many periods are there? 1, 2, these are horizontal rows. So these are horizontal rows is known as 1, 2, 3, 4, 5, 6 and 7 till 7 periods are there. So we could, if we are going to count these horizontal lines, we could easily recognize that how many types of elements are being placed. So the atomic number 1 is of hydrogen, which is placed here in the first group. Then second is helium, this is placed here. It is present in the 18th group, fine. And then this is having the second, 2 in number of hydrogen, this atomic number, but still it is placed here in the inert gas. So this is the 18th group, which is known as the inert gas group. Okay, so third is lithium, fourth beryllium. Okay, then after that more on carbon, nitrogen, oxygen and fluorine. Then neon is there in 18th group. So the 18th group only consists of this last one. This consists of only the inert gases. Okay, that is helium, neon, argon, krypton, xenon, radon, and the last is and it is also unknown. Okay, then after that what with this 118 elements, so 108 total 118th element is being classified, which would come here at last. Okay, next thing is that how would you say that there are different metals, non-metals and the inert gases are present. So I must tell you where is the position of all these elements and how they are classified in this periodic table. So what is the group number? Group number 1, 2, 3, 4, 5, 6, 7 till 18 group numbers are there. So please remember, and 7 periods are there. So please remember, these are the horizontal rows and these are the vertical columns, which we are numbered as the groups. Okay. Now the metals are coming from this second period till it is going to come till 13. So all these are metals. Okay, so here except these two, this lanthanum and actinium series, this is there. So lanthanoids and actinoids are different. Okay, I'll tell you just after that. I'll tell you the number which is going to come from 58. The cesium till deuterium, this is there, which is going to come in the lanthanide series and lutetium, and then after that from actinoids it starts from thorium. Okay, this is going to end up in 103rd element, whose name is the lawrencium. Okay, its name is Lr. Its short form, its formula is Lr. Okay. After that, what you will do is what you will see is that the metals and non-metals you have to understand. So these are all metals. Okay, so all these are metals. Fine, from this 13th group and till here, this one. So in this manner, this is all is about the metalloids. Metalloids means it is going to show as the different properties same as the metals as well as the non-metals. Then where are the non-metals? Non-metals is this one, this H, and from this carbon, whatever is left in the 18th group all will come under the column of, under the metal, under the non-metal group. Okay, so I'll just tell you about that. These three are the ways, these three positions are being placed. So what we have been placing? We have placed the metals, the non-metals, and the metalloids. Between them, the metalloids are there. These have the position in the modern periodic table at different places. So these zigzag lines are also being shown here, and we could easily understand if you are able to see a colored diagram of this modern periodic table in your book. Okay, that would become more easier for you all to understand, and it is very difficult for me to draw all these colorful diagrams over here. Okay, so I have just given you a basic concept, and children, if you could be able to see the diagram in your book, that would be well and good. Please look at the diagram now only, and then you will understand what I am talking about. So please remember that modern periodic table is the most latest one. If you can learn the elements which are present in different groups, and if they are present in the different periods, you can learn them very well. That is the most that would be a very best part of your study, that you learn this modern periodic table. Okay, as much as you could learn at least the first, second group, third group, and at least 18th group everybody should learn. Okay, next is that we'll find that this modern periodic table, the elements contain the same number of valence electrons in the first group. Okay, so I'll discuss all these parts in the next part of the video, children. Okay, so I had just given you the basic concept about this modern periodic table and the concept of where is the placement of these three types of elements: metals, nonmetals, and the metalloids. Okay, children, so that was all about the modern periodic table for today. I'll meet you all in the next video with the next topic to be discussed, and I'll continue with the same topic of this modern periodic table in more details. Okay, so that's all for today's video. I'll meet you all in the next video.